So the first question is, how do we add fractions with the same denominator? Something like 1/5 plus 2/5. The denominator tells you how big a slice is, and the numerator tells you how many. So if the denominator is the same, then we can just write the whole thing with one denominator and then copy the problem there. By copy the problem, I mean this here. It's easy breezy. It's like saying that I have one quarter and two other quarters, that's together 3/4. And this helps with positive and negative numbers. For example, 1/7 minus 3/7 is gonna be, you just copy the subtraction, and then the problem is reduced to signed numbers, positive and negative integers. So we're gonna get -2/7, which is the same as -2/7. These are the two, I think we discussed this. You can keep the negative sign with the numerator or in front of the fraction. Technically, this would be, we start with -2 and we divide it by 7. And this would be, we take 2/7, and when we're done, we take the opposite of that. These two are the same. You know, I talked so badly about mixed numbers. So let me just state that sometimes life might be easier if we just leave mixed numbers, like 3 and 2/5 plus 23 and 1/5. You see, 23 and 1/5 as an improper fraction, that will take you up to large numbers. So it might be just that you say, okay, let's add the bills with the bills and the coins with the coins. And 23 plus 3 is 26. And 2/5 plus 1/5 is 3/5. Of course, you can have some complications, such as 2 and 3/4 plus 7 and 3/4 would be technically 9 and 6/4, but there are all kinds of problems with that, right? First of all, that's the same as 9 and 3/2, and that's a strange mixed number. How can we rewrite this as a correct mixed number? The problem is this is too big for a fraction part. How can we rewrite this? But 3/2 is 1.5, right? So that makes more sense. That's one complication. And every time you're dealing with complications like this, you remember that going with improper fractions is always an issue. This is just sort of a shortcut in case something makes it inconvenient. Probably the toughest part is when you have something like 5 and 1/3 minus 2 and 2/3. So the problem now is that 1/3 minus 2/3 would be a negative thing. And with mixed numbers, they have to have the same sign. It's either positive, positive, or negative, negative. So the problem is when we subtract 2/3 from 1/3, that's negative 1/3. So we cannot say +3 and negative 1/3. Well, we could say 3 plus negative 2/3, and that's 2 plus 3/3. This is called borrowing. Basically, imagine that you have $3 and then you make change for $1. So you're left with $2 and here is the change. And that's 2 and 1/3. You can borrow right here too. So you can rewrite 5 as 4 plus 1. And these are all pretty reasonable things. I don't want you to panic and memorize them one by one. These are pretty reasonable things to do. So you can say 5 is 4 plus 1 or 4 plus 3/3. And then 5 and 1/3 minus 2 and 2/3 would be 4 plus 3/3 plus 1/3, right? This is just 5 here. 5 and 1/3 minus 2 and 2/3. So we have 4 minus 2 is 2, and 3 plus 1 is 4, minus 2 is 2 and 2/3. We should get the same answer. So my issue right now is that we get a different answer. That's always a red flag. 5 and 1/3. 5 and 1/3 is 3. Oh, there it is. Right? 1 minus 2 is -1. All right, so these are kind of reasonable things. And you can always just, whenever you see a mixed number, you can always just step 1, go to improper fractions. Even if numbers are biggish, well, you have calculator with you. So that's completely up to you. So this is how we deal with fractions with the same denominator. Now, how do we add, subtract fractions with different denominators? We don't. It's like you have 3/4 and 2 dimes. 3/4 and 2 dimes. We cannot say, well, you can say we have 5 coins, right? But that's not going to express how much money we have. We're just going to have this physical thing that we have five metal coins. But if you want to express meaningfully how much money we have, how much money is this? 3/4 and 2 dimes.
95 cents.
Right. So cents, that's 1/100. That's a common denominator, basically. Okay. So we need a common denominator. Now, if we think about money, we're not going to get the best common denominator, which in this case would be 20, right? 20 is a multiple of both 10 and 4. But if we're generous and we go up to 100, then 4 times 25 is 100, 3 times 25 is 75. Indeed, we know that 3/4 is 75 cents. And then we know that 2 dimes is 20 cents. And now that we have a common denominator, we can add the top. So whenever we're counting, it has to be the same thing. Otherwise, what we're saying is meaningless. And there is nothing that you could do that would make sense with 5, as in 3 plus 2, because we're adding different things. So basically, before we add fractions, we have to bring them to the common denominators. And with the common denominator is try to get the least or lowest common denominator. This was kind of an exception, because if you don't work with the least common denominator, it's just more work, more danger. Your numbers are bigger, which means more work, more danger. So try to keep it low. So for example, 2/3 minus 6/. Okay. What's a good common denominator here? What's a good common denominator here?
Could it be 12?
That's the best one, actually. Exactly. And so, well, you can speed it up. Maybe if this is brand new to you, you can go 3 to 12, that's multiplication by 4. 2 times 4 is 8. But eventually, you're not going to need this intermediate line. You can just go and 1 bar, 3 to 12, that's multiplication by 4, must do the same thing to the top. And then 12 to 12, nothing to be done, is 1/12. Yeah, if this is brand new to you, which I hope it isn't, then you might need this intermediate line, and then you continue here. What's a good common denominator? 20. Oh yeah, keep repeating myself. So we can write 20. And it's going to be a subtraction between, well, 4 to 20 multiplication by 5. 1 times 5 is 5. 10 to 20, double. And now we have a subtraction between positive, negative numbers here. We get -9/20. This is cool, or this is cool. Notice the location of the negative signs. These are equally simplified. Now you can use borrowing with mixed numbers, but I just want to show you a more general way. If you have an integer and a fraction, you can always think of the integer as itself over 1. So we can very quickly rewrite it as 3/1. And 1 is a very polite denominator because the least common denominator is whatever the other number wants, right? So 8 is good enough. And then 1 to 8, we multiplied by 8. 8 times 3 is 24. Indeed, 24/8 is still 3. Minus 8 to 8, nothing to do. So we get 17/8. I don't mind that it's an improper fraction. It should be in lowest terms, but otherwise I don't mind.